Hello! In this video tutorial I will present the scanning and data post-processing of the technical sample part, which created triangle mesh can be used, for example, for reverse engineering. For the scanning process we used Micron 3D green scanner with the field of view of 400 for 300 for 240. To fasten the scanning process we will also use the rotary stage. Object will be scanned from 3 positions. For the first position, we will scan the top surfaces of the object. The most important is to set up the scanner in position to the object, which allows us to scan top surface and also internal cylindrical surface presented on the screen. First, put the object on the rotary stage for setting up the scanner. Remember about the lasers. Object should be in the middle of the volume, so the lasers should cross in one point. Set up the proper angle of the scanner to the object. To capture the surfaces, the angle from 30 to 45 degrees will be OK. If the position is set up, you by using the calibration plate define the axis of the rotary stage. After the calibration, put the object on the rotary stage and start the scanning process. We will scan the object around with the step of 30 degrees. For scanning the bottom surface, change the position of the object on the rotary stage. In this position, the most important is to scan the bottom surface and the edge of the bottom surface and perpendicular surface showed on the screen. Also, it is important to scan the cylindrical surface. We will scan the object in this position with the step of 30 degrees around. For the scanning in third position, we want to capture the edge between bottom surface and perpendicular surface presented on the video. For scanning process, we have to change the position of the scanner and the angle of the scanner to the object. Because we changed the position of the scanner, the calculation of the axis has to be repeated. When the calculation is done, put the object on the rotary stage and start the scanning process. Now we can start the data post-processing, the cleaning, aligning and creating the triangle mesh. As you can see, we have 3 groups of clouds in the model tree. Each group refers to the scanning from each position presented earlier. We will clean it one by one. For the first group, we will use the algorithms. For the rest, we will create the automation process using the operations and parameters which were used for cleaning the group 1. Go to Points tab and select Color option to delete darker points which are less accurate and their quality are worse for creating the triangle mesh. Using the bar or by typing the 55 in text box, select points, press OK button and delete. Next, go to Non-Continuities option and select the radius of 4 mm. We are going to use this option 3 times with different radius to remove the non-continuities points. After the calculation, using the bar, change the value of select point further than to 1.4 mm. Repeat the operation for 2 mm with this parameter of 0.6 mm and 1 mm with the parameter of 0.25 mm. After that, remove the contour of the clouds with one constant value. Go to Contour, press Select button, change the value from 1 to 0.2 mm, press Expand button, press OK button, and after that press Delete button. Now we can make the first global registration to align more precisely the clouds of group 1. The alignment will be done with default settings. After alignment, analyze the cleaning of group 1. We delete these kind of points which might have influence after in the alignment process. For the cleaning of group 2 and 3, we will create the automation process with the options and parameters which were used for cleaning of group 1 with additional option of remove the groups of points. Go to Automation tab and press Edit button. Press New button, set the name, and from the list select the options and the parameters. Now I'm going to add those operations. After that, press the Save button to save the automation process. The automation process will be added to the list of available automations. Press OK to apply the changes. Run the automation process and wait for the results. Operations will be performed one by one. After that, I advise also to analyze the cleaning. In this case, I will also delete some points. You might wonder why I deleted the bigger part. Because the points were darker than others, and may cause problems with perfect alignment later. I also know that I have the information of this part of the object on other scans from group 1 and 3. When the scans are cleaned, we have to align them to one coordinate system. In this case, we will use manual registration of 3 points method. Select all the clouds from group 1 as stable. Using the Control button, we can select the clouds one by one. Using Shift button, select first and last cloud of the group to select all the clouds. Select the clouds from group 2 as 2 feet. Select common points of the groups and align them. Repeat this operation also for alignment of group 3. After manual alignment, the global registration should be performed to find the best position of the clouds between themselves. In fitting series, add 2 rejection radius for 1 and 0.5 mm to minimize the moves and rotations of the clouds. Change the search engine from random to all points with threshold 10. Every 10th point of the cloud will be selected for the alignment. As the result, we will have more points counted for the alignment, but the time of alignment also increases. The report of alignment also appears. The maximum error is about 44 microns. After global alignment, I advise to check alignment of the scans by comparing, for example, the surfaces or by virtual cross-section as the view presented in this video. To create the triangle mesh, go to Triangle tab. Select all the visible groups from the model tree and press the Create button. Make sure that Optimized algorithm is selected and press the Create button. As you can see, the triangle mesh is created. Of course, there are some holes we can fill using the option, but for the quality inspection, we should make few more measurements to capture those surfaces. For reverse engineering, this model could be used to create the CAD model.